In this video, I'm going to share with you how the Compose Param Transformer works and how it's architected. The goal of this transformer is to take a composable function such as this and to add in the compose parameter and the change bit mask. These parameters should also be propagated to nested function calls. So what is the architecture like? All of the transformers, they all inherit a class called abstract compose lowering. And what this class has are utilities and all the visitor methods. So this class, abstract class, inherits an interface called IR element transformer void. And what this has are many visitor methods, and you could optionally override them. Like visit class, visit declaration, it has 164 visitor methods, and you could optionally override which one you want. That's what all the transformers do. So this abstract class also has utilities and extensions that all the transformers need. So it has about 52 extensions and helper methods. Here's an example of one of them. Many of the transformers need a reference to the composer object, and this is what it does. It creates an IR class for the composer, which is the parameter that we're going to add in. It also contains utilities such as being able to detect whether a function has the composable annotation. So let's look at how this transformer is architected. So it overrides a method called visitSimpleFunction, and what it does is that it gets a declaration. Every time a function is visited, no matter if it has the composable annotation or not, all the functions, when they're visited, this method is called. Keep in mind that what we're doing here is that we're modifying an IR tree here. So the code like this, it gets converted to an IR tree that looks like this. And there are different elements in here. If we want to add in our own elements in our plugin, we want to be able to modify this IR tree. The first thing you'll see in here is that it has a function, which is an IR function type. It also has annotations that we're able to detect. It also has a body that we're going to use in the future to be able to wrap around our own bit masking logic. So the first thing that we need to do is that we only should do this transformation for composable functions that have this annotation. So we need to check basically whether this annotation exists. In order to do that, as I shared before, we could reuse a utility that the abstract compose lowering class already has, which is a method called has composable annotation. If it doesn't, we just return and don't do any modifications. An IR function is a type that has IR value parameters, and there could be many of them depending on the number of parameters you added. I have utilities. I could use builder methods to add in my own IR value parameters. So how do you add a composer reference to that? First thing you need to do is to create a class ID, and you specify the name of the type that you're going to use. And this is part of the Kotlin compiler that we're going to use, part of the core module called class ID, and we're going to specify the package name, the relative class name. And you'll see in the Compose compiler plugin that it creates this class ID for the composer object. The next thing that we need to do is actually go and create a reference for it. All the Compose transformers, they're injected with or provided with a context. IR plugin context is used to get the actual reference. And what the context is, it's an interface. It has methods to reference classes, type aliases, etc. And that's what we're using here. I'm using that context to reference the class, just like this. And it gives me a composer IR type, just like that. So how do we go and add this to the actual function? Well, there is a method and utility provided by the Kotlin compiler called add value parameter, and it takes in what is the name that you want to add and the type, and whether it's nullable or not. And it looks like this. So over here, I'm basically taking that function and I'm using this method called extension called add value parameter. This is the utility provided by the Kotlin compiler. And the first parameter is the name of the compose parameter that I'm going to use, which looks like this. It's an identifier, just like that. And then I'm going to specify whether it's nullable or not. So as you can see right there, when I execute that code, this is what it looks like. It adds in a value parameter in the IR tree right there, as you can see, and it adds the type to it and the name of it. So I'm also specifying whether it's nullable or not, or whether it's assignable or not. So this is the pattern used to add value parameters to a function, to a IR function. There's a utility that's really useful to be able to look at the generated source. This utility is only available to the Compose compiler plugin. It's not a utility that's in the Kotlin compiler. So the Compose compiler plugin has a utility called dump source, which is an extension on an IR type that you could use. And when you utilize this, you could print out basically the generated code, which looks like this. This is what we have so far. We just added the composer method. We also need to add in this change method, this change parameter, which is a bit mask. And we'll go deep down into what it means and how it gets added in the next video.